Hello everyone, welcome back to our channel As Geek. I'm Chandan Soni. This is differentiation lecture number 5. In the previous lecture, we studied derivatives of standard functions. In this lecture, we are going to solve problems based on that. Before we begin with the problems, let us revise all the derivatives of standard functions. First one, derivative of any constant is 0. Derivative of x raised to n is n into x raised to n minus 1. Where n is an integer. Derivative of a raised to x is a raised to x into log a. Derivative of e raised to x remains as it is, e raised to x. Derivative of log x is 1 by x. Now coming to trigonometric functions, derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Derivative of sec x is sec x tan x. I repeat, derivative of sec x is sec x tan x. Derivative of cos x is minus cos x cot x. If you notice over here, number 7, number 9 and number 11. The trigonometric functions begin with the letter C. Cos x, cot x and cosec x. The derivatives of all these three functions, cos x, cot x and cosec x, they all are negative. Minus sin x, minus cos x square x and minus cosec x into cot x. So these are the standard functions whose derivative you should know very well. Let us begin with the problems now. While solving the sum, you should know derivatives of sum and derivatives of difference. What is that? If u and v are differentiable, if u and v are differentiable and y equals to u plus v, then dy by dx equals to du by dx plus dv by dx. That means derivative of y with respect to x is same as derivative of u with respect to x plus derivative of v with respect to x. Similarly, if y is u minus v, then you can say that dy by dx is du by dx minus dv by dx. So this is derivatives of sum, derivatives of difference. Simple basic rule, you will need this while solving the problem. In the later stages, I will explain you derivatives of product as well as derivatives of quotient. So you can pause the video over here, note it down, then you can proceed with the problems. Exercise: differentiate the following with respect to x. Differentiate the following with respect to x. So let us look at the first question. First question is x raised to 4 minus 2 sin x plus 3 cos x. Let us denote this complete function by y. Let y equal to x raised to 4 minus 2 sin x plus 3 cos x. As you can see, I have got one differential function over here, 2 and 3. So we are going to use both sum and difference rule over here. So let us start. Differentiate y with respect to x. So what do we get? Dy by dx is what? Derivative of x raised to 4 minus 2 sin x plus 3 cos cos x. Using the sum and difference rule, what we can write? dy by dx is derivative of x raised to 4 minus derivative of 2 sin x plus derivative of 3 cos x. Now before you differentiate, focus over here. I have got 2, that's the coefficient, and I have a 3 over here. Put them aside. So dy by dx is derivative of x raised to 4 minus 2 into derivative of sin x plus 3 into derivative of cos x. Now let us differentiate. So dy by dx, over here we use derivative of x raised to n. So what is my n over here? 4. What is derivative of x raised to n? N into, that is 4. N into x raised to n minus 1, that is 4 minus 1. Minus 2 remains as it is. Derivative of sin x is cos x. 3 remains as it is. What is derivative of cos x? Minus sin x. Remember, derivatives of all the functions starting with the letter c, they are negative. So what's the last step? This will be 4 x raised to 3 minus 2 cos x plus minus 3 sin x, and we are done. So the function was x raised to 4 minus 2 sin x plus 3 cos x. When you differentiate, what do we get? 4x cube minus 2 cos x minus 3 sin x. Pause the video over here, copy the problem, then proceed. Now let us solve the second question. Second question is 3 raised to x plus x raised to 3, that is x cube, plus 3 raised to 3. Carefully we will solve this problem without making any mistake. So be patient and go step by step and work out the sum slowly. So let y equal to 3 raised to x plus x raised to 3 plus 3 raised to 3. Differentiate y with respect to x. So what do we get? dy by dx is derivative of this function with respect to x, that is 3 raised to x plus x raised to 3 plus 3 raised to 3. Use the sum rule, separate all the functions. So dy by dx is derivative of 3 raised to x plus derivative of x raised to 3 plus derivative of 3 raised to 3. Just to recollect, remember that derivative of a raised to x is a raised to x log a. Derivative of x raised to n is n into x raised to n minus 1. We are going to use them over here. So if you see 3 raised to x, how does it look? 3 raised to x, a raised to x. 3 raised to x, a raised to x. Fine. Next one, x raised to 3. X raised to 3, x raised to n. X raised to 3, x raised to n. Okay. We'll discuss this later. So, what is dy by dx? 3 raised to x, instead of a, we have 3 over here. What is the derivative of a raised to x? A raised to x log a. So, what will be derivative of 3 raised to x? 3 raised to x log 3. 3, first part is done, plus x raised to 3, x raised to n. What is that? N into x raised to n, that is 3, n minus 1, plus. Now look at the third part. This is 3 raised to 3. Is it a raised to x? Is it x raised to n? Think over here. Neither it is 3 raised to x nor x raised to n. What is 3 raised to 3? 27. So it's a constant. So 3 raised to 3 is a constant, and what is the derivative of a constant? 0. So let us simplify it further. 3 raised to x log 3 plus 3x. What is 3 minus 1? 2. So we can just write this as 3 raised to x into log 3 plus 3x squared. So derivative of 3 raised to x plus x raised to 3 plus 3 raised to 3 is 3 raised to x log 3 plus 3x squared. Pause the video over here, copy the sum, then you can proceed with the next one. Let us solve third question. Let us solve the third question. Let y equal to 1 upon sin x plus 2 raised to x plus 3 plus 1 upon log 3 to the base x. Before you differentiate, just check whether it can be simplified. If yes, then please simplify it, then start differentiating. Okay? So if we know that 1 upon sin x is cosec x. This remains as it is, 2 raised to x plus 3. And if you remember the log rule, what is log rule? Log of a to the base b is same as log a upon log b. We will use this over here. So this is 1 upon log 3 upon log x. We can simplify it further. So what is y? Cosec x plus 2 raised to x plus 3. So that comes out, this becomes log of x upon log 3. Now it has been simplified. Now if we can begin with the differentiation. So differentiate y with respect to x. So dy by dx is derivative of cosec x plus 2 raised to x plus 3 plus log of x on log of 3, bracket close, differentiating this with respect to x. Now using sum rule you can separate them. So dy by dx is derivative of cosec x plus derivative of 2 raised to x plus 3 plus derivative of log x upon log 3. Okay, we'll erase this part. So what is dy by dx? What is dy by dx? So dy by dx is derivative of cosec x. Before we differentiate, let us simplify this portion. Plus derivative of 2 raised to x plus 3 plus over here is 1 upon log 3 acts as a coefficient. Okay, so you can keep it aside. So plus 1 upon log 3 into derivative of log x. Now you can differentiate this. Dy by dx, what is that? What is derivative of cosec x? C. Okay, we have letter C, minus cosec x into cot x. Now how does this look? 2 raised to x plus 3. This looks like a raised to x. So instead of x we have x plus 3 over here. So what is that a raised to x derivative? A raised to x into log a. So first part is done. Okay. Second part is done. We get third part. What is that? Plus 1 upon log 3. What is derivative of log x? 1 by x. Let us write the final answer over here. So dy by dx will be minus cosec x into cot x plus 2 raised to x plus 3 into log 2 plus 1 upon x into log 3, and we are done. So derivative of 1 upon sin x plus 2 raised to x plus 3 plus 1 upon log 3 to the base x is minus cosec x cot x plus 2 raised to x plus 3 into log 2 plus 1 upon x into log 3. So this was question number 3. Let us solve one more problem. Now we will solve question number 4. What is that? Log of x to the base 3 minus 3 log of x to the base e plus 2 tan x. So let us start. Let y equal to log of x to the base 3 minus 3 log of x to the base e plus 2 tan x. As I told you, if it is possible to simplify the function, please simplify it. Over here we have log of x to the base 3. Over here we have log of x to the base c, and we know that log of e is 1. Now, what can be done? You can write this as log of x upon log 3 minus 3 log of x to the base e. We know that derivative of log x is 1 by x. That log is with the base e. So derivative of log x to the base e is 1 by x. So you can keep it as it is. Plus 2 tan x. So let us begin. Differentiate y with respect to x. So dy by dx. You can directly apply the sum rule. That is derivative of log x by log 3 with respect to x minus 3 into derivative of log of x to the base e plus derivative of 2 tan x. Okay, so I can write this 2 over here. Let's make a small change. 2 into derivative of tan x. So what is dy by dx? We can keep this log 3 aside, and is 1 upon log 3 into derivative of log x minus 3 into derivative of log x to the base e plus 2 into derivative of tan x. So the last step now, dy by dx equals to, what is derivative of log x? 1 by x. So this will be 1 by x into log 3 minus 3. What is derivative of log of x to the base e? It is same as log x. That is again 1 by x. This is 3 by x plus 2. What is derivative of tan x? Sec square x. So when you differentiate log of x to the base 3 minus 3 log of x to the base e plus 2 tan x, when you differentiate with this with respect to x, what do we get? 1 upon x log 3 minus 3 by x plus 2 sec square x. So we have solved 4 problems today. In the next class, we will be solving derivatives of product and derivatives of quotient. Till then, practice all the solved problems. See you in the next lecture. Thank you.